Okay, this is the second video here on lesson 3.3, and this really gets into the heart of the lesson, which is verifying an identity. They'll use another term besides verifying here, but the big idea behind this is we're going to have an identity or an equation here, and what we have to do, there'll be multiple choice questions. We have to pick the choice that correctly goes through and explains why this statement, like for instance right here, would be true. And so I just want to start off with an easy one here, and then we're going to go really not to working problems, but then looking at strategies in doing this. Now, one of the strategies here that we'll talk about to verify an identity is to change everything to sine and cosine. And this would be probably a good identity here to do that with. Now, so we can look at tangent here, and we can write tangent as sine over cosine. And keep in mind what we're trying to do, the big picture is what we're trying to figure out is, how is this true? Okay, so how does, if tangent of theta is multiplied by cosine of theta, how is it equal to the sine of theta? And so verifying an identity is sort of like a proof, and you're showing the process of why that it's true. So let's look, and what we're going to do here is we're going to change tangent to sine over cosine, and that's certainly a good strategy in this case here. So I would write this as the sine of theta. Let me start it off this way. I'm going to write it sort of the way your multiple choice answers write it here. So let me start it off and write tangent of theta times cosine of theta. And now they do everything across instead of working vertically, which I don't really care for, but I'm going to kind of work the way they do so you guys can familiarize yourself with sort of going horizontal instead of working vertically here. And so what I'm going to try to show now is this is somehow equal to the sine of theta. So let's do what I started there here. Let's change tangent to terms of sine and cosine. So that will give me here sine of theta over cosine of theta. So that's rewriting tangent times the cosine of theta. Okay, now at this point we probably see why that's sine. So when I multiply sine over cosine times cosine, the cosine thetas there are going to cancel out. And so now I've verified here that sure enough, that is the sine of theta. Okay, so understand when you verify an identity, you're basically doing a proof. It's like you know what the answer is, but you have to show how it's true. That's the best way I can really describe that to you. Okay, now that we've got a general overview by what it means to verify an identity, or the way they say it is to establish the identity here, let's look at a list of strategies here that we can use to help us pick out the right or the correct answer. Now, one thing here that you can do, I am going to save this as a PDF file, so you don't really need to take notes during the video. Just try to pay attention, and maybe what you could actually do is print off the pages in the PDF file and maybe follow along and make notes on them here. Now, this first strategy, we've actually already done this strategy in the first problem. Now, keep in mind, when I'm going to do these problems, I'm not really going to work the problem out, but what I want you to understand is just have an understanding of the strategy. The next video that we do, we will actually take the problems and work them out and look at the answers, look at the multiple choice answers, and actually work the problem out and pick the multiple choice answer. Now, so this one, that first strategy, and this is usually my favorite strategy to do, is to change everything to sine and cosine. So if we notice this one, we've got secant times the sine of theta equals tangent of theta. So I'll write this out the way it's going to look here for us to pick. So secant theta times sine theta. Now, let's keep working on this until we can figure out how to get it to tangent of theta. So let's use that strategy of changing everything to sine and cosine. So we should be fairly familiar with the fact here, if I have secant of theta, that I can write that as the reciprocal here, which would be 1 over cosine. So secant is the reciprocal of cosine. And so now I have 1 over cosine theta times sine theta. Okay, notice nothing's canceling out here. But if we multiplied this out, then we would get sine theta over cosine theta, which that should look familiar. What's that? Sine over cosine is tangent. So I've actually worked this one out completely there. And so I'm sure the correct choice here would be very, very similar to what I've got there. So that's using the strategy here of changing everything to sine and cosine. Okay, next one, I'm going to actually do a couple of these. Now, I'm not going to work these out. So what we can look at here is using Pythagorean identities. Now, when I'm looking to use a Pythagorean identity, what I'm really looking for, we've talked about this before here, is I'm looking for ones that are squared, okay? So squared ones and ones. Okay, if I see squares and ones, that should be a hint that I could probably use something here with a Pythagorean identity. So let's look at the first one. We should spot this one almost right away here. We've got 1 minus cosine squared. So we should be familiar what sine squared plus cosine squared is 1. So 1 minus cosine squared would be sine squared. And so on the next step of that, verifying that, I would change that to sine squared and then continue. Now again, I'm not going to finish it. I'm just looking at the strategies here. All right, on the second problem, what I could do here, notice I've got 1 plus sine theta, but that doesn't say 1 plus sine squared theta. I do see some ones there. Okay, so that kind of helps me there. I don't know what happened to that, but it just disappeared. Now, here's what I do see here is I have a cosine. I've got a cosine squared there. Okay, so let's see what we can figure out here about what we can do here about that cosine squared. So that Pythagorean identity here that we can use with this, let me write it above, sine squared theta plus cosine squared theta is equal to 1. So cosine squared theta would be equal to 1 minus sine squared theta. So I could take probably in the first step of verifying this identity here. Let me rewrite this. There again, I'm going to write it sideways to kind of illustrate how they do that. And so I could write this as 1 minus, and now instead of putting cosine squared right there, we could put in place of it that cosine squared would be 1 minus sine squared theta. Now, the reason why you would do that is probably kind of puzzling to you, but I think you'll see this kind of in a later strategy here where you would see in this point why you would do that. The idea is this you have this on the bottom, and so that looks really, really similar. So we'll kind of get to that strategy in just a little bit. Okay, let's go to the next strategy here. Okay, our even and odd identities. So recall, what I'm going to do probably in this case is something similar to this. If I have the sine of, say, negative theta, then this is equal to the opposite of the sine of theta. And so in this problem in particular here, notice that really looks like one of those Pythagorean identities, and it is, but it's got negative theta in there. And so what I'm going to do here, that's cosecant, so it would be very, very similar to sine. And so this would just give me negative cosecant of theta, but then this would be squared though. And so if I squared that, then that would just make that positive. So that would just be cosecant squared theta minus 1. And you probably realize, well, hey, that's probably going to be a Pythagorean identity at that point. Okay, next strategy. Find a common denominator. Okay, so probably when I would use this one would be when I would try to add two fractions together. So let's look at an example here, not verifying an identity, but maybe somewhere where I'd want to use this. All right, so first off here, I'm writing tangent of theta plus cotangent of theta. We said, well, those aren't even fractions. But what if I changed everything to sine and cosine there? What if that was my initial strategy? So we'd write sine theta over cosine theta because that's tangent, and then cotangent is cosine of theta over sine of theta. Now, don't get all cancel happy and go to canceling. We can't do that. That's addition there, not multiplication. Now, so doing that, I'd say I've got two fractions. And so one idea here that I could do with those two fractions is take them and write them as a single fraction. And so to do that, I would have to get a common denominator. And so we could probably be able to tell here the common denominator would be cosine theta, sine theta. And so now let's get the idea here. If I went from cosine theta to cosine theta times sine theta, then I had to multiply by sine theta, which means I'm going to have to multiply the numerator there by sine theta. And so sine theta times sine theta would be sine squared theta. Now, let's go to our other one over here. So I'm going from sine theta to cosine theta sine theta. So I would have to multiply that denominator, the bear, by cosine theta, which means I need to multiply my numerator by cosine theta. And so cosine theta times cosine theta, right now my plus sign, would be cosine squared theta. And I'm not going to continue here, but if I was to continue to try to do something with verifying what this is actually equal to, you might notice, or you probably should notice, that that's a Pythagorean identity in that. Now, let's go to the next one. Okay, number 5, factor to simplify. So let me give you an example here where I could use this idea. Let's say I ended up something here, let's say sine of theta plus sine theta cosine theta over sine theta cosine theta. Okay, so with this idea, you might thinking, oh, there's probably some stuff I can cancel out right there, and that's sort of true here, but I can't go through and just say, well, I'm going to cancel those out and then those out. That's not going to work. You remember the idea of canceling here. If I'm going to cancel something out, the operation has to be multiplication, so I can't do that. Now, the way I can make it into multiplication is by factoring though. So notice in the numerator here, I could factor out a sine theta. So that will give me sine theta times 1 plus cosine theta over sine theta cosine theta. And now notice what I can do here. I could cancel out the sine thetas because now their operations that they're doing there are multiplication. And so this would leave me with 1 plus cosine theta over cosine theta. Now I couldn't cancel out the cosine thetas, especially with the top one there, the numerator, because the operation is not multiplication on that quantity. Okay, next one. Factor a difference of squares. Now this one's going to be probably kind of hard to recognize here, because when you see it, you probably think more to use a Pythagorean identity. But let's look at it. And so probably as soon as I wrote that, you were probably thinking Pythagorean identity, and that would probably be, a good thing to think about here. But then look at what I'm going to put for the denominator. Okay, there again, I can't cancel anything out because the operations are not multiplication. But look at the title of this. It's factoring a difference of squares. So where's the difference of squares at? Well, one's a square, and sine squared is a square. So I can factor that like it was a difference of squares. So kind of think of an algebra thing here. What if I had 36 minus x squared? Well, you guys would tell me real fast here, that'd be 6 minus x times 6 plus x. So I can do the same thing with 1 minus sine squared. Well, why would I want to do that? Well, you probably kind of tell some's going to cancel out when I do that. So let's factor out 1 minus sine squared. I could write as 1 minus sine theta times 1 plus sine theta. And now let's bring over 1 plus sine theta. Now that the operation is multiplication there, I can cancel out 1 plus sine theta, and that just leaves me there with 1 minus sine theta. Okay, next one is to change the functions to look like the answer. Now, I've actually pulled an identity to do this one. And so what I want to illustrate with this is that this has 1 plus sign on the left, and supposedly this is supposed to give me this somehow. Well, notice, we should see a relationship there. Sine and cosecant are reciprocals of each other. So what we can do here is we can change that sine function to look more like cosecant because they are reciprocals. Okay, so let me show you what we're talking about here. Let me rewrite the first one. Okay, so instead of writing sine theta, we could write that as the reciprocal. Well, sine is the reciprocal for cosecant. So I could write this as 1 plus, now the reciprocal of cosecant would be 1 over cosecant theta. And so similar on the bottom here, I could say this would be 1 minus 1 over cosecant theta. Okay, now it might be kind of hard here to see where this is going with this, but that's one thing I could do to start off. So we might not be sure what to do on that next step just yet here, but we'll get to that. Okay, so again, that's just using the idea that I want to make what's on the left look like what's on the right. So I'm making these signs look like cosecants there. Now, another strategy here is called the reciprocal strategy. Now, I really dislike this one, but because these problems are multiple choice, we're going to have to force to use this strategy here. Now, the idea here, let me kind of start off with basic numbers, is if I have something to this effect, just a simple fraction like 2/3. Well, what I can do with that is I can write that as more of a complex fraction here, is I can write that as 1 over the reciprocal. So this one could be written as 1 over 3/2. Okay, now let's take the same idea here with this problem. And there again, I wouldn't, if I had my choice, I would not do this problem this way, but we're kind of forced to do it the way the multiple choice answer has done it. Now, so let's take this one. So we got secant theta over secant theta minus 1, and supposedly somehow this is going to end up being 1 over 1 minus cosine theta. Now, so what we're going to do is that reciprocal idea here is this would be 1 over the reciprocal of this value. So this would be 1 over And then on the bottom here would be secant theta minus 1 over secant theta. Okay? And now it may be kind of hard to realize what to do from that point there, but that would be a strategy. Now, the way I recognize this strategy is just by looking at the multiple choice answers. Usually you can recognize to use this strategy by looking at the answers ahead of time, looking at the choices to see. And a lot of times you'll figure out the strategy from looking at the answer choices. We'll have more on the answer choices in just a second about how we can manipulate the answer choices sometimes to just go straight to the answer. Now, let's look at this one. I like this one, splitting a single fraction here. So in this case, notice it's a single fraction. And so what I might can do with that is split it into two fractions. And so notice I would basically, it's kind of like finding a common denominator, but doing the opposite of that. So the denominator there is sine theta cosine theta. So I'm going to do this. I'm going to write both fractions that have sine cosine theta as their denominator here. So I'm going to put minus in between them because we're subtracting the two values in the numerator there. And so now what I can do is split the top here. So I could write this as sine theta over sine theta cosine theta minus cosine theta over sine theta cosine theta. So notice how that works. If we were to go backwards with this, that's what we would wind up with because we have a common denominator. So all I did was split that common denominator to both of the terms in the numerator. Now, let's notice, well, why in the world would I do this? Well, take a look at each single fraction now. Now that they're separated into two fractions, notice that all you have is multiplication in each one of those. And so since they're sort of independent fractions there, we can do some canceling. So sine squares would cancel there. And so that would just leave me with 1 over cosine. And then the cosines would cancel there. And so that would leave me with 1 over sine. Now, you may realize how this one would actually work here. 1 over cosine is secant, and 1 over sine is, how about that, cosecant. Now, let's look sort of at some multiple choice strategies here. And what I'm going to do is I'm going to bring in some of the problems, or one particular problem here to show you this. Okay, so this first bullet says, look at the last step and ask yourself, does it make sense? Okay, because if you have something that's not true, then that's not going to be one of my answers, and I can eliminate that choice. So let's actually look at a problem here. I'm going to skip forward and look at this actual multiple choice question of verifying the identity. Now, notice that it looks kind of really overwhelming when you do this. Now, it kind of helps me to break it up here into different steps. Okay, so in this case, they're sort of taking 2 or 3 steps here to do this. Now, so when I look at the last step, I'm just going to ask myself a question, and I'm going to just ask, well, does that make sense? So let's look at choice A right here. The last step on choice A says that the cosine of theta over the sine of theta is equal to tangent theta. Wrong, okay? Think about that. What's tangent of theta? Tangent of theta is sine over cosine, not the other way around. So that last step is wrong. I don't care what they got on the first few steps. That is just simply not going to work. Okay? Now, look at the choice B. Now, this is more like it. On the last step right there, they have the sine of theta over the cosine of theta is tangent of theta. Now, that's correct. And so B would still be a possibility. Okay, now look at choice C there. So on choice C, they have the same thing. Sine of theta over cosine of theta is tangent of theta. So that seems to be okay also. Now look at choice D. It's kind of what they had in choice A. Cosine of theta over sine of theta equals tangent of theta. I don't think so. Okay, so that one, not going to work either. Now, let's go back and then let's look at another strategy here that's going to involve my multiple choice ideas. Okay, so second bullet there. Look at the first step. Again, does it make sense? Okay, so let's go back and let's look at the first steps. So I've already eliminated the first and last choice from the last step. Now let's look at the first step. So in the first step here, they're going from sine of theta times secant of theta to sine of theta times 1 over cosine theta. And so if we look at that, we ask ourselves, does that make sense? So let's see, they're going from secant of theta, and they've changed it to 1 over cosine of theta. So is that valid? Is secant 1 over cosine? Well, yeah, it is. So that step makes sense. Okay, I don't know if that's maybe right, but at least that step is right. Now, look at the next one. And so the next step goes from sine of theta times secant of theta to secant of theta times 1 over cosine of theta. So they've done the same thing there. They've changed secant of theta to 1 over cosine, but then look what happened to sine. I don't know what happened there. They went from sine of theta to secant of theta. Well, sine of theta and secant of theta are not the same thing there. So that first step does not make sense. So that eliminates that one. So I haven't really even done the problem, and I figured out the correct choice. Now, most problems here are not going to be that easy, but I do believe on most of these problems you can eliminate half of the choices just by using that strategy. Now, let's look at another strategy here that I'm going to look at and kind of take advantage of with multiple choice here. And so that's look at the first step in each choice to figure out what's a strategy here that they're using. So let me kind of clear this off, or let me just copy it to the next page here. I'll just do that. All right, there we go. Now, so if I was, actually working this out, and I'd prefer that you guys try to work these out on your own in the beginning here. Surely you can eliminate a few choices by those, but you really need to see the actual steps when you work them out. Now, certainly on a test, I would say go by the fastest method, okay? But when you're doing the homework, you sort of need to look at this as working the problem out, not just trying to choose the best answer. Now, and so when I look at my first steps here, right, especially what I'm noticing here is that they're, in most of those cases, maybe it's with the exception of C there, but they've went from secant to cosine over sine there, okay? And that doesn't really make sense. But then on the next one here, they went from secant of theta to 1 over cosine. Same thing on the third choice. They went from secant to 1 over cosine. Same thing here. So what they're doing is they're using the strategy there of changing everything to sine and cosine. Now, again, you'd probably want to print the PDF file off on this to kind of help you realize that. And the next video is actually going to go through and actually work through them and look at the choices and answer the questions.